Yo, what's up peeps, it's MasterWire, and we're back with a tutorial. Not often do I get requests, but when I do, I try to go all out. So let's do a dodge roll tutorial and open up a new Unreal Engine project. We're going to use a blueprint project, and let's see, quality max. We don't need to mess around with any of that. We don't need any of the variants either. Let's just call this dodge roll and create. So all right, we have a basic project here. I want to go ahead and open up the character folder, mannequins. Let's go to rig, get the CR mannequin body. We're not going to do the logic for the roll just yet inside of the blueprint. We'll do that. We'll do that later. What we want first is just something visual to use. Once we drag that into the world somewhere, which I just like to put it somewhere where it's flat on the ground, we can make sure we're in the animation mode and start animating. So for a dodge roll, what I'd want to do is first, let's go to content, back to the content folder, and you'll see that the CR mannequin body take 1 has been created here. Let's make a new folder called mannequin, mannequin animations, and just move it here. All right, once that folder is made, inside of here we have our base animation. We don't want to mess around with this one. We want to make a copy of it and start editing this. All right, so to realistically roll, the way that I am imagining this is we just need specific poses. So we don't need to actually animate the roll itself. We just need key poses for the roll is the way that I like to do things. And we'll blend from key pose to key pose in order for our roll to always remain equal to the amount of distance we're going. So I'll show you what I mean. And this is an easier way to animate it too, so that you're not like some kind of animation savant, you know, sitting here going keyframe to keyframe. No one wants to be doing that. So just moving the pelvis down and then moving the feet back a bit. These circular bones right here. Let me turn the camera speed down. It's a bit better. These circular bones here can be rotated, or spherical bones can be rotated, and it'll give you a bit of a pivot. So I'm rotating this while moving the foot back to attempt to get like a knee down pose. Moving the pelvis back a bit will be necessary, and the actual knee bone here is under the level, unfortunately, so you have to go in there and look at it. But once we have it, we'll be able to drag it out like this and have ourselves a more realistic starting pose. What I'm achieving here is just the start to the roll. I was thinking we might as well have a start keyframe to this to reference ourselves with, and we won't mess around with this pelvis origin bone. Instead, we'll grab the spine here and then rotate this. But whenever we mess around with the spine, let's just go ahead and grab all the spine bones. That's a rule that I like to try to follow so that things stay natural. So grab all the spine bones and rotate them all at the same time. And now we have like a crouch on the knee pose here. So this can be the beginning of the dodge roll itself. Doesn't have to be too specific. And we actually don't need to really mess around with the arms right now. We can just leave them the way that they are. And you don't want to do anything like exit this right now. You want to go all the way to the top and then keyframe all the bones by clicking this button here on the CR mannequin body. After we've done that, we could either copy this and begin our roll from this position, or copy the original. I'm just going to copy this pose that we've already made and start from here. Might be easier first. Let's think about what a roll is. From this position, I would either have the body completely toss itself to the left, to the right, forward, or back. So I would need all the directions figured out, and we could even do diagonal directions. We could like author those specifically. If they don't blend well whenever we show them in the actual blend space, we might just want to do those as a specific direction on their own, and then blend between the blend spaces. So maybe we'll use 1D blend spaces for these. That might actually be the cleanest way. So a basic forward roll, what's going to happen is the foot's going to push back technically. The body is going to arch forward. The pelvis is going to rotate forward, and we're gonna do that 90 degrees. So first things first is to rotate the actual pelvis bone 90 degrees. But what I wanna do at the same time that I'm doing this, since we may not even need contact for this 90-degree pose, I'm thinking we don't. So what I want to do is inside of the animation itself, all the way at the top, click on the global, and we're going to change the legs from the IK to FK. And then the arms, we can do local off for the arms. And then the pelvis can be rotated 90 degrees. And basically our job here would actually be to make sure that it looks good in all rotations. So I want to move the pelvis back to the center. I believe that's almost centered. Let me see what happens when I rotate this. Yeah. Oh, I can just look at the location here and then -60. That's fine. So moving this and then grabbing the actual bones for the body here, the pelvis and the spine one, moving that back so that this original pelvis bone, this root bone here, stays our center, and then we can rotate around this. So that's the idea. There's a setting that you can have on here, which is create key when channel property changes, and we actually would want to have that on so that whenever we make these changes, it'll stay. All right, now we can rotate 90 degrees and attempt to make this pose at 90 degrees make sense. So what I think we should do first is turn on the local space coordinates so that we're rotating the bones on their actual axis. I think if we're rolling in this position, our legs would be tucked, sort of how this one is. Cool. Now we should rotate the spine a bit more. Obviously the neck and head need some help here, so let's rotate those as well. And for this to be believable, obviously your head wouldn't just be contacting the ground like that. So the arms are going to be what catches your fall whenever you originally hit the ground. So we want to animate that. Basically a pose where you're crossing your arms over your head. This is enough. Now we can just grab these bones here, move the body completely down, turn the grid to 5. You can change the grid size up here and also the rotation amount and the scale amount, but we're not going to scale anything. And just move the body down a bit so that it's contacting the ground realistically. Let's make sure that everything is keyframed. It should be, but always good to double check. And go ahead and save all, might as well. All right, nice. So that's saved, and we can just duplicate this, and we want to repeat that process. So the important thing is to rotate the pelvis 90 degrees, and let's make sure we're doing so for the correct animation here. Double checking. Nice. Now that it's rotated 90 degrees, we just need to make this animation make sense for this pose. So it already kind of does, but I would rather the tuck should be a bit more complete here. That's what I'm looking at. So let's go to move the leg down a bit and angle the legs in. Fix this here. That's basically what I want. And then yeah, the full pelvis bone can just be rotated a bit more in. And let's see if we can do anything with the spine. We probably shouldn't. The spine itself can be a bit more down so that the back contacts the ground more realistically. The head position is fine. The arms do make sense. I'm wondering if this is too animated though. That's the only caution with this animation right now. Hands behind the head. We can probably extend the arms a bit so that these can be, like the arms can be shown and not like under the ground. And then we'll just choose one of them to offset from the other. That looks fine. Go ahead and keyframe all the bones. Copy that. Let's make a duplicate. Let's rotate 90 degrees. Repeat the process. Let's move these bones down so that the back is still contacting. And this is basically the end of the pose here. So if I'm thinking about it as the very next pose is technically going to be this one, this is pretty solid. What I would want to do is begin to complete this pose here and maybe even angle the back up just a bit more. And we can do the single spine rotations here. We don't really want to mess around with it too much, but this looks good. And then the arms would be the only thing to begin to settle into like a more natural pose. Cool. Okay. So that completes the rotation. Cool. Now I'll show you what this looks like. Instead of doing all the different directions right now, I'll just show you these 4 directions and what it can accomplish. So after you have these made in the sequencer, in order to get these put inside of an actual animation for to use, let's create a folder here and let's just call it animation. Okay, what you want to do is go into the CR mannequin body and then bake animation sequence, and we'll choose our animations folder that we just made here, and we'll call this mm underscore roll underscore neutral. And am I explaining this right? Okay. CR mannequin body, right click on it, bake animation sequence, animations folder, then go ahead and call it whatever you want, roll neutral, or we're on the roll down right now. So forward or neutral, forward, then down. And then this last one is going to be back. All right, and now after we have those made and inside of the animations folder here, we could do select all of them and then retarget all the animations. We might want to save everything before we do the retargeting because sometimes it can crash your Unreal. Nice. Now select all of them, retarget animations, click our mannequin CR, or not even CR, it's SKM mannequin simple, and find our roll animations. Just double click on it just to make sure. Good. Select all of them, export animations, go to the animations folder that we have everything else in, export, include reference assets can be unchecked, but check the overwrite existing files, and then export. Cool. So those have been retargeted, and basically what that means is the bones for, I'll show you actually, go to the eye here on the top, and then go to bones and select the all hierarchy so we can see that now the IK bones are following our hands as well, which wouldn't have been the case if we left it without the retarget. So nice. And what we'll be able to do with these roll animations here is put them inside of its own animation blend space. We'll go to the legacy and use the blend space 1D for this. We could use the regular blend space if we wanted to blend all of them together, but I don't think it'll work too well doing that, since we're not really doing rotation animations, we're doing keyframed animations. So select the SK mannequin and call this BS for blend space, and we can call it roll, or geez, we'll call it roll underscore Y, which means if you're rotating the Y axis, it should be this. And put the neutral in, put the forward in, back, down. And we'll put down for the end and the beginning. And we can immediately see some of the stuff that we might want to like change a bit. Like the way that the arms interact with the ground here is the only, really my only concern. Because everything else looks pretty solid. And honestly, we could keep the arms the way that they are. It really wouldn't look too bad, but it is something that's fixable. It would just be from this animation to this one. I would actually animate the arms to rotate outwards a bit. But, you know, it's a bit much. We could just, we could rotate these lower arm bones to go in a bit more with this animation here, so that it's more pressed into the ground, and that would just make it make more sense. So that's the benefit of using the keyframe method for this. And with the actual timing for this animation for the horizontal axis, we can do negative 180 to 180. And we don't need the weight speed. That's fine. And that's all. So we want to do that basically for each direction. Same deal, every direction. And we already have backwards and forwards just off of this one animation. So you would just need to do left and right, and then the diagonal left, diagonal right animations. All right, so how are we going to drive this roll animation? There's a few different ways for us to do it. The cleanest way would be timelines, but I'm just going to brainstorm a bit and we'll work through it as we go, and just see if we can figure this out. So what I imagine is we're first going to need an input action. So I'm going into the input folder here and going into actions. Let's just copy the IA jump and rename it to dodge. It's a Boolean. We don't need to change anything here. Inside of the input folder, IMC default, we can do the drop down here and see that we can add another mapping, which is going to be our IA dodge. Let's click the keyboard here and then use our left shift so we can say IA dodge is the left shift input. Save and exit. Now, if we go inside of our third person and inside of the blueprint and open up our third person character, we would see that we could begin adding our dodge roll logic directly in here. Normally what I would do is make a separate component for it, make a folder called components, make a blueprint class actor component and call it BPC dodge roll. And then what I would normally do is add that BPC dodge roll by searching for it inside of our BP third person character in the components list and adding it here for us to use. All right. Let's just use this component. So inside of the BPC dodge roll, event begin play, we'll want to get our BP third person character. Get player controller or get player pawn actually. Promote this to a variable, our BP third person character for us to reference. And what do we need referenced for the dodge rule? Basically the direction, but we don't really need that right now. We just need to know that it's active and that BP third person character is pressing the input. But we could probably just directly link the input inside of here and say IA dodge. Whenever we press IA dodge, we attempt to start the dodge. So let's make a function here. Let's call it try dodge. Pull out try dodge. On started, we try the dodge. If try dodge allows us to actually dodge, then we start dodge and finally end dodge, or first we update the dodge, then we end dodge. So these are the functions that we need. I don't think we need anything else. Maybe a dodge implementation for the beginning if we're getting this call for the character, but it's just if we need to expose that to the player. We don't really need to do that right now, so this is fine. Start dodge. What this does is we make a branch, and we'll need a variable for this called dodging. Is dodging. Get is dodging. If is dodging is true, then do nothing. But if is dodging is false, then we should be able to start dodge. And when we start dodge, let's go ahead and click in there. We set is dodging to true. End dodge, we set is dodging to false. Update dodge. Is dodging would be set to true technically, but there's no real reason to if it's already set in start dodge. Only if we encounter some kind of glitch which doesn't allow this to work. So nothing is actually, doing anything just yet. What happens when we start dodge? So when we start dodge, we should do update dodge, and let me get this update dodge here. Branch. We don't need anything to activate the update dodge. We just need to know that is dodging is true. And if it is true, then we begin adding the increment. And we can make a variable off of this inside of our update dodge. We're just making a regular variable, not a local variable. We can call this roll. So it's going to be updating the roll on tick. What activates this update dodge is the tick component. So let's just go ahead and plug the tick directly into update dodge. When update dodge is false, I'm thinking it should just set the roll to 0. That makes the most sense to me. And we would need to finally set it to this added increment float. We can clamp the amount, clamp float, before it is able to be set, and say that the greatest amount that it can be is so and so, like the max can be 180. But what we might want to do instead of this is some sort of additional branch to say that if the roll is greater than 180, if whatever amount we add is greater than 180, it should flip and go to negative 180 and increment down from there. So since our roll is from negative 180 to 360, that's the reason we're doing it this way. And it should allow us to roll backwards and forwards since we have that too. But let's figure this out. So we'll need a print string greater than 180. So if it's a greater than 180, it'll do this print string, set the roll to negative 180. And I don't really want the print string all the way back here. It should be before. And it should just read whatever the roll amount is. Start dodge is dodging is true. Do nothing is dodging is false. Set is dodging to true. Then update dodge is allowed to happen. It begins. If it goes over 180, then it'll reset back to negative 180 and continue. So it should start adding it and be incrementing from 179 to 178, a negative 179, 178, and keep going. It should be a pretty clean loop. But anyway, let's test it out. Looks like it's working. We may see a bit of a stutter in the animation itself. So that, that'll reveal itself if it is an issue. Now, what I want to see is how this affects our animation itself. The final value for this roll value, we should be able to expose this inside of our animation blueprint. So in the character folder, under mannequins, animations, unarmed, go to ABP unarmed. And under event graph, we can pull from the character and find our BP third person to cast a BP third person character. Just plug that into the stack here for a quick check. As BP third person character is set to a variable, we just pull that from here and then promote to a variable. And add a new sequence pin here. Get our BP third person character and get roll. Where's it at? Oh, because it's inside of our dodge roll component. So what we would need to do is first get dodge, get BPC dodge roll, convert to validated get, plug in the sequence, BPC dodge roll, pull out from here, get roll. Now this roll value, we can promote this to a variable for our animation. Compile after we plug it up, and that'll work just fine. So inside of our actual animation graph, which you can get to that, you can get to the animation graph from here too. But in here, we need to set up inside of the main states or the locomotion what the roll state actually is, like what that means. So it could just be a new walk state, and from dodge roll, or we should get is rolling as well. Is dodging, promote to a variable, plug that up, and once we have that inside of our walk run, which is inside of the locomotion animation folder, we can give us a little bit of space here and completely say that the walk run animation is taken over by the roll. It's just one way of doing it. Type in bool, blend poses by bool. True and, we get a true and false. So plug the idle and walk into false, and then the true is going to be the BS roll Y. The value for the BS roll Y is going to be the roll. And there's no way to shut off the roll right now. It's just going to keep rolling once we do it. Oh, we actually get nothing because we didn't put the is rolling Boolean or is dodging Boolean in. Now it happens, but only while we're moving forward, because it's connected to the locomotion. So if I stop, it does nothing. But if I start going again, it'll go back into the roll. We can see that we're obviously going to need a few other things. Let's can we multiply this? I don't know if we can. We might be able to add. Let's add 5 to it and see if that gives us some more speed, and yes it does. So this is basically the idea. And what's easy about this is you can go back in and author these animations to make it look more realistic if you want. You can tweak the speed and make sure that it matches up with the ground pretty well, which I think it does right now. And you get yourself a dodge rule. Now, how do we stop the activation for it? We have a timer. So basically, how long can the dodge exist? And that should be done inside of update dodge. So we can say that this should update the dodge timing. So let's get a new float here. Call this dodge timing. Use a float. Get our increment float again, and we'll put it before the increment float that's running the dodge itself. Let's rename this variable to dodge. Dodge value, actually. Let's make a new variable for this. Or we actually don't need a new variable. We have the dodge timing already. Get that. And set the dodge timing as well. Once is dodging is true, it'll run this, but we can do another branch once dodge timing is greater than like 30 or something. Then we would set it to, we'll set dodge timing back to 0, and also set the dodge value to 0, and set is dodging to false. Let's see if that works out of the box. Looks like we might have broke something. Oh, we need a not Boolean, because this should be reversed from true and false, and that does what we want. So now all we need to do is figure out either some math to make sure that the dodge timing is always enough time for us, or something else. And obviously we don't really want this always connected to the walk run state. So let's take this somewhere else. Inside of the main states, we can do a state alias, call it to dodge, pull from to dodge and make a new state, call it dodge. Inside of dodge, Of course, we either want this or just go ahead and paste the one that you copied if you did. Connect the roll amount to it. We can rename this to dodge value since that's what it is. In order to go into the dodge, we get is dodging is true. If is dodging is not true, we can just directly go back into the locomotion or make a new state alias for that. But I'm just going to do is dodging is false. To dodge this state alias would need a global state on it. Or you can say that you can go into this from locomotion, land, and that's it. That way we can roll in place if we want. We haven't added any logic to move the character around with the roll. This is just the roll itself. And of course it's a bit long. 100 is not the right timing for it. So I need to think in multiples. So basically right now I'm multiplying this by 5. If I multiply it by 2, then the dodge timing would be 90. Let me see if I'm correct. That's right. So what I should do is do some math. Let's get a division float. 180 will always be divided by the dodge multiplier. And that will give us our greater than amount. Get the dodge multiplier and put that into the addition for this, for our increment. And then we can say it's like 4 for the dodge multiplier. And that'll give us faster dodges, but always, it could be a bit longer though. Dodge multiplier. So 180 divided by 4. Let's multiply by 0.5, which is a bit extreme, but just to test it out. And yeah, that's basically the behavior that I want, but it should be about 0.8. Now we can set the timing for dodges and like the timing for the dodge animation just with math, just with some simple values. So if you have all this set up, you're in a good spot. This value here, dodge multiplier, and let's promote this to dodge lag time. Now we have something pretty clean. So all that's next is making the actual logic for the dodge, like to move the character around and not to rely on the character movement itself. Or you know what? It just does in dodge. So I could do a little cool little timer here inside of the in dodge. Like just go ahead and create it, because I believe this is going to be ticking anyway. Yeah. Set is dodging to false only after we do an increment. Let's call it a dodge cooldown. Promote it to a variable. Oh, I don't need to do that again. Set dodge cooldown. If branch cooldown, or not branch, if dodge cooldown is greater than a certain amount, dodge cooldown amount. So if it's greater than whatever amount we set, then it would do something else other than add. It would set the dodge cooldown amount to 0, and it would also set is dodging to false. And our dodge cooldown amount can be like 10 seconds or something. Oh, we got an issue. I want to see what this is doing. I see. So it's not allowing us to... We should immediately set is dodging to false. And then the in charge here should do something completely different. Let's do can dodge Boolean. Set can dodge to true whenever the dodge cooldown amount exceeds the, or whenever the dodge cooldown exceeds the dodge cooldown amount. Set can dodge to true. Try dodge. Let's have another branch here. Can dodge. If can dodge is true, then we're allowed to do this. What sets can dodge to true in the very beginning is, I guess can dodge is already true. Can dodge starts out as true. We don't need to set it here. We just need to update dodge. We set can dodge to false whenever is dodging is true. And the only way to set it back to true would be through the end. Let's see if that works. Looks like it's not ticking. The reason it isn't ticking anymore is the moment we set can dodge to false. Let me see. No, that won't affect our update. Can dodge is false. Maybe this end dodge should just be on a separate thing. Update dodge and then end dodge can be on the tick as well to make sure that it works. The only way that this happens is if is dodging is false, or I see that I'm setting the dodge cooldown amount to 0, which is wrong. I should be setting the dodge cooldown itself to 0. That's a lot of the problem, honestly. What I did is I'm just going to use the can dodge. So if not can dodge is true, then we're going to go ahead and execute this for the end dodge, which is just a dodge cooldown amount should be greater than the dodge cooldown, or dodge cooldown itself should be greater than the dodge cooldown amount. If that is true, then set the can dodge to true and dodge cooldown to 0. And if it's false, we're going to continue to add the dodge cooldown so we can increment that. What's setting can dodge to false is the update dodge. So if update dodge is updating with is dodging, then can dodge is false. And then it never sets it back. So that's the reason for this. Now for the dodge cooldown amount, we can set this to like 25 or something, or 50. Yeah, it works just as planned. So pretty good stuff. 200 is a bit extreme. 100 might be more realistic for this. And we'll be able to use the same timing for when we run our actual launch for the dodge. All right, so how do we launch the character and make it so that this is more realistic than just rolling in place? So fastest, easiest way that we could possibly do this is to grab our as BP third person character inside of our BPC dodge roll component. Let's just get, and then get the velocity, get last update velocity character movement, and we'll use this. So with this, we'll be able to pull from the BP third person character again and do launch character, and we would be able to move our character without using launch character pretty soon too. This is going to be a universal role, but for now, launch character is going to be just fine. And you'll see that you'll be able to roll in all directions. And if we were to jump, we would be able to do like a jump roll of some sort. The only issue is I can do that because I can keep pressing while dodging. So in order to get rid of that glitch, we still want to use this launch character here. Just copy this, and inside of start dodge, we can put it there. That means it's already being locked out by a lot of our other logic, meaning we shouldn't be able to spam it. And yep, it should just play whenever start dodge is actually available. Now, if we wanted some more power for that, what we would do is multiply this by a float, promote that to a variable, dodge power 2, and we get a bit more of a boost. It's momentum based, so it sort of behaves how you would expect, where if you were to be moving in one direction for a minute and try to go in the other direction, the dodge is going to be a bit slower. But if you were moving in the same direction, you could make it much, much faster. More realistically, 1.2 would probably be best.